Hi everyone, and welcome back to another thermochemistry example. This is going to be question 9 from the workbook. It's on page 21, and it goes like this. In a coffee cup calorimeter, 1.6 grams of ammonium nitrate is mixed with 75 grams of water at an initial temperature of 25 degrees. After the dissolution of the salt, the final temperature of the calorimeter contents is 23.34 degrees. Assuming the solution has a specific heat capacity of 4.18, and I think I used 4.184 in my calculation. That's what's in our data booklet. And assuming no heat loss to the calorimeter, calculate the enthalpy, delta H, of the dissolution of ammonium nitrate in kilojoules per mole. So essentially what we've got happening here is 75 grams of water in a coffee cup. The initial temperature was 25 degrees. We're going to add 1.6 grams of ammonium nitrate. The solution will go up or down depending if it's exothermic or endothermic. In this case, the solution temperature will go up or down depending if it's exothermic or endothermic. In this case, it went down. It's endothermic. Okay? So knowing that initially, I should be thinking to myself, okay, this is an endothermic reaction. I'm looking to calculate delta H. The delta H of an endothermic reaction will always be positive. So in the end, I should be getting a positive answer for delta H. And knowing that initially when I start will help me, because if I forget one of the main steps in the calorimetry problem, I'm going to end up with the opposite sign of my delta H, which is what I don't want. So knowing it right away that this is endothermic, I should be thinking to myself, okay, positive value for delta H at the end of my reaction here. So let's get into the solution. We'll go step by step through all the calculations. All right, so I have everything written out here, and just like every calculation problem that I approach, I always write down everything on the side of my paper that I start with so that it's easily referenced if I need to go back and look for a particular value. So we start off with 1.6 grams of ammonium nitrate. There's 75 grams of water. The initial temperature was 25. The final temperature was 23.34. I did the delta T right here just as a sort of a time saver later on. So final minus initial, I got a negative 1.66 degrees for delta T. There's my specific heat capacity, 4.184, right from the data booklet, of course. And I also calculated the number of moles here because I'm pretty sure I'm going to need moles eventually. So moles of just the ammonium nitrate, so 1.6 grams divided by 80.04336, that's the molar mass of ammonium nitrate, gave me 0.019989. And I did not round this value. I kept this the same, all my digits. I'm not going to round anything until my final step. All right, all calorimetry problems have 3 basic steps. So first, Q of solution. Second, Q of reaction. Third, delta H. Q of solution is your MC delta T, mass of solution times C, specific heat capacity, times delta T. So this is a really common mistake that a lot of students will make. They will forget to add the solid and the liquid for your solution, right? Your solution is 2 things, solid, solute, liquid, solvent, okay? So we're going to add those 2 together to get the mass of the solution, then multiply it by 4.184, and then multiply it by our negative delta T here. And I get negative 532.020 joules. And again, I'm not rounding anything. I'm going to wait till my final step to round. All right, once I have my Q of solution, the next step is where my solution or my sign is going to change for my Q. Okay, so Q of solution is showing me negative 532. I want the Q of the actual reaction. It's the opposite. Everything in thermochemistry, right, is equal and opposite. Okay, so if Q of my solution looks like it's exothermic, Q of the reaction is actually endothermic. It's the opposite. So I'm just changing the sign here. But I really like to see this in a lot of the worked examples. This is a really important step, and also another one that's easily forgotten, which will affect your delta H value in the end, which you don't want. So Q of reaction is positive 532, but same value as Q of solution, just opposite sign. Third step is to calculate your delta H. Delta H is Q reaction over N, over the number of moles. So my Q reaction from step 2 here, 532 joules, and then number of moles, and this is just the number of moles of the solid that's added to the liquid. Okay, the solid dissolving is what is causing the temperature difference here. So if I had 1.6 grams of ammonium nitrate, that corresponds to a temperature drop of 1.66 degrees. But you can think about it, if I had 5 grams or 10 grams of ammonium nitrate, I'm going to get a bigger temperature drop. It's going to go down even further, right? It's going to require more energy coming in to get that solution to dissolve. So when I want to find my delta H, the number of moles here is only the number of moles of the solid that's placed into your water, into your solution. It's not the whole mass of solution, this 1.6 plus 75, and that's another big mistake that a lot of students will make. They will take this mass solution and change it to a mole value. So you really don't want to do that. We want just the number of moles of the solid that got added to the coffee cup calorimeter. Okay, so that corresponded to 0.019989 moles, as I calculated here earlier. And then the last calculation is delta H. Delta H is Q divided by N. And you can see it's quite a large value, 26,615, because this is in joules again, right? Because my Q is in joules. Delta H is typically reported in kilojoules per mole. And a very easy way to do this, obviously divide by 1,000 to get this into a kilojoules, but doing this also takes care of my significant figures. If you look back at all of the values that we had, 3 significant figures is what I'm kind of shooting for here in my answer. So by changing this joules into kilojoules, I'm getting my 3 significant figures at the same time. 26.6 kilojoules per mole. Notice this value is now a positive, right? This is a positive value, which is what I want. I know the reaction is endothermic, so I'm looking for a positive delta H in the end. There's several other questions in the workbook that you can try like this, and actually your thermochemistry lab is very, very similar to this particular calculation. So this will be a great one to reference when it comes time to do your lab on this particular topic. All right, that's it for this video. If there's any questions, of course, as always, you can let me know. And good luck with all of your thermochemistry calorimetry examples. And as always, thanks for watching. Bye.